Okay, we're going to look at a great problem here from our book. Find the nth derivative of f of x equals 2x plus 3 to the n. Now, your first thought here is to say, okay, well, that's n times 2x plus 3 to the n minus 1. Okay, well, that would be the first derivative of 2x plus 3 to the n. But I want the nth derivative of 2x plus 3 to the n. So you could do the second derivative of 2x plus 3 to the n, but that would be too weird. Here's what we notice. This n here and that n here, they're the same n. So let's set up a little table and see if we see a pattern. So let's make n here. Let's let f of x be here. And then let's let f prime of x be here. And let's do 1, 2, 3, 4. Okay? This is like that old game show, Name That Tune. Right? So these contestants would get on there and they'd have about 3 notes and they'd have to try to name the song. Okay? I'm going to give you 4. See if we can see a pattern. So here we go. When n equals 1, what is f of x? If you said 2x plus 3, you would be correct. So what would the derivative be? The first derivative. Oh, that's 2. And now let's let n equal 2. So this becomes 2x plus 3. And actually, this shouldn't be f prime of x. This should be f to the n of x. Right? So n equals 1. So now I'm looking for the second derivative of 2x plus 3 squared. I'm going to repeat that. The second derivative of 2x plus 3 squared. And we can do that. So what's the first derivative? Well, the first derivative is going to be 2 times 2x plus 3 times 2. That's the first derivative. So let me pull in another board here because this column is going to be a little wide. Okay? There's the first derivative. So that's 4 times 2x plus 3. But now we have to get to the second derivative. What's the derivative of 4 times 2x plus 3? Oh, that's 8x plus 12. So that derivative is 8. So this is, why don't we underline this? This is the first derivative. There's the second. Nice. Nice. Let's do a pattern. Let's do another one. Let's do 2x plus 3 cubed. Now, here's what I want. Say it with me. I want the third derivative of 2x plus 3 cubed. This is a great test question. All right, so here we go. 3 times 2x plus 3 squared times 2. So that's 6 times 2x plus 3 squared. Everybody with me why there's a times 2 there? Okay, so this is what? There's your first derivative. All right, put a little arrow. What's the next derivative? 12 times 2x plus 3 times 2. So that's 24 times 2x plus 3. There's your second derivative. Oh, this is going to be great. So then, what's the derivative of 24 times 2x plus 3? Well, that's 48x plus 72. So that derivative is 48. There's your third derivative. 2, 8, 48. Pattern. Maybe not yet. All right, let's do it again. 2x plus 3 to the fourth. I need the fourth derivative. Can we do it? I don't know. It's a little scary. 4 derivatives. Can we do it? I think we can. Let's do the first derivative. 4. What's a derivative of something to the 4th power? 4 times something cubed times the derivative of something. Plus 3 cubed times 2. Oh, that's 8 times 2x plus 3 cubed. That, my pups, is your first derivative. Let's do the second derivative. 24 times 2x plus 3 squared times 2. So that's 48 times 2x plus 3 squared. There's your second derivative. Whoa! How about your third derivative? 96 2x plus 3 times 2. So that's like, what's that, 192? 192 times 2x plus 3. That's your third derivative. What's the derivative of 192 times 2x plus 3? Well, that's 192 times 2. 200 times 2 is 400. We're going to minus 16. So that's 384. There's my fourth derivative. So the question is, what's the nth derivative? Is there a pattern? Is there a pattern? Okay.
I think I found the pattern.
Uh-oh. Well, that's okay. I'm going to give it to you anyways because we're running out of time. So you got 2, 8, 48, 384. And I got n, 1, 2, 3, 4. So you're going to be doing this in the spring, by the way, pups. So this is actually a good lesson. This is all series. So you got 1, 2, 3, 4. Qu'est-ce que c'est the pattern? Well, wait a minute. This is 2 times 1. This is 2, 8. Be like, wait a minute. 2 squared times 2. This is 8 times 6. 2 cubed times 6. How about 384? 384, let's see, could that be 2 to the 4th times 12? Is that right? Is 16 times 12 384? Oh, times 2 again. Sorry. 2 to the 4th times 24. Do you recognize 2, 6, and 24? Come on, math counts, kids. You should recognize those. 2 to the 1st times, 1, 2 times 1, 1 factorial. 2 to the 2nd times 2 factorial. 2 to the cubed times 3 factorial. 2 to the 4th times 4 factorial. 4 times 3 is 12, times 2 is 24, times 1 is 24. Oh. So, 2 to the nth times n factorial. How about them apples? You like apples? How about them apples? Anybody? Anybody? Now you can speak. Tell me that reference. You like them apples? How about them apples? You like apples? How about them apples?
Good Will Hunting.
You just got an A in the class.